Hello, everybody. Good evening. Our topic for today is image encryption, efficient encryption and compression via random permutation. So, what does image encryption mean in today's world? In internet taking over all phases of our life, image encryption is very important in our day-to-day life because for us, social media is very important, and we randomly and send through images through mails, texts like Facebook, WhatsApp. We send images everywhere. So protecting the images is also very necessary in order to protect from the like without any issues or anything. There are many places like where banks etc image encryption is highly necessary, and protecting the data is also very important. So in our project for today, what we have taken up is like how we are taking the images in the traditional methods we follow. First, when we choose an image to encrypt, we first compress the image, then go through the encryption process, and then decrypt. But today, in our project, which we took up, in order to not go for any transmission losses and securely transmit the images, what we have done is we have first encrypted the images and then went through the compression process. In our progress to the project, we have found various online tools and developed a C and Python code where we can encrypt and decrypt images with utmost security. So, uh, if I like our team, my teammates for this project is Pelumi, it's me, Shweta, and Michael. So we are going to present through this topic today. And these are our table of contents where we have just tried to give in the overview of the project, what we have did, what are the issues we faced, what technologies we used, and what are the results and its conclusions. So we'll go through about it now. So, as I mentioned just now, like here, image encryption is very necessary and very important in our day to day lives, and like how wrong usage of it can lead to harsh attacks. And if our images are not encrypted and not decrypted, like whatever we send through emails or WhatsApp or Facebook, we can be at a greater risk. So like how we can securely transmit them is about our project today. So this is our ideology, like how we are going through about lossless transmission in our project, and like how we are managing the compression part and storing it, that is being discussed. So if we go through our overview diagram, here we can see that the we have a set of users. I mean, like where first the encryption is happening, then the compression is happening, then similarly, uh, vice versa is happening on the decryption side. First, it's getting decrypted, and then the decompression process is happening. For this, we are using random permutation and pixel shuffling. So this process we have elaborated in our project, and it'll go through in our slides. So in technical specifications, as I just mentioned, we have used random pixel shuffling and random permutations. We have also developed a code in C++ and Python, which can also encrypt and decrypt images. And we have found various other online tools where uh, encryption and decryption can happen at just one click, and why this is very important. So let me now show a slide demo of an online tool which we found while implementing our project. So this is the one online tool which we found. There are many tools like this here. To encrypt an image, first, like we just upload any image to this tool. I am just choosing an image here and clicking on encrypt image. After a while, we can see that my image is encrypted and I have received an encrypted image. I can also download it and use it at a later point of time, or if I want to transmit any secured images, I can go via this process. Similarly, decryption process is happening. If I download this image and upload it again in other tools or in our code, we will be able to retrieve back our original image. So all these process will be later explained by my teammate Pelumi. He'll continue from there.
Thank you, Sweta, for your explanation. So I'm just going to go through what we implemented and the challenges faced during our development process. One major challenge we faced was we were not going to use like common algorithms like AES or RSA, because what we tried to implement is like a block for block permutation and encryption process. And so we had to just kind of like search for resources online through our referencing and just try to come up with a custom code. I'm just going to share my screen. Okay, and so the code is in C++ and Python. And so what we're basically doing is sec. So the slice to the function, what this does is it kind of like breaks down the image into like slices. So that's where the block for block encryption process comes from. So we kind of like have to rearrange the images by pixel. And so that's what this function does for us. And so the encryption process, basically we get a block of from our image. We get a block where we set the output height, the output width. We resize our output to this set output height and width. We try to slice the images into different blocks, and we scramble it. So once we have that, we have to scramble the image. We scramble it, we rotate it, we invert it, and then we negate it. We try to like change it into like a black and white image. And so that's basically how the encryption process goes. It's similar to the decryption phase. So we have to first of all negate it. We go from down to the top now. We negate it. We invert the image. We rotate it back same way it was encrypted. We scramble it basically, and then we have our output, and it's basically our image. So that's basically our image. So Sweta, you can bring up the slides again. And so basically that was how we went through implementation of our algorithm. And so some of the challenges faced were we weren't very proficient with C++. We had to like try to start learning how to code in C++, how to write functions in this language. And then the Python bit was basically just the main.py file, which is where we call the implementation done in C++. And we tried to add some arguments to it so you could pass the image directory where you want it saved, and all of that. And so this is basically our code and other snippets. So our code works exactly how the online tool works. You pass the image into it, you pass in the directory you want us to save it to. And so once it's done doing the encryption, it saves the image back into that file. So one thing we noticed was that our implementation was better than some free online tools, as we added the decompression phase into this. And so basically the image sizes of our output were about 2 times smaller than what we're getting from online. So most times when you encrypt it using online tools that we try to use, it kind of increases the image size. And so our own method tries to take care of that and make sure that the image is still compressed and can be transmitted securely, and also um, yeah. And so for our algorithm, basically what we do, we take the image we are trying to encrypt, choose a random image online or any image you're trying to send, maybe on social media or wherever. You select the image, you run the main.py file, you pass in the inputs and the output directly into it. And so what the code does is it kind of like tries to rearrange the cells, um, rearrange the pixels, converts it back uh, into grayscale because that's the negation phase, and then we compress it to make sure it's as small as possible. Because the encryption phase kind of like add a lot more size to it because it removes the pixels as the image is done captured. And so that's what our algorithm basically does. And the compression basically as so this is the example results. We passed in the Statue of Liberty, and this is what we had back. So I'll just respond to Mike to conclude.
Thank you, Palumi. So, in conclusion, we were able to create an efficient encryption and compression system, which was being made possible by using random permutation. And it was able to help us generate a very encrypted data, in this case, an encrypted image. And it, it, it gives our image more secure, what they call it, more secure, uh, would I say, it's more secure data that won't be able to be accessed by unauthorized users or unauthorized access. So we were able to achieve this by using random permutation. And during this project, we came across different image encrypting tools, and it showed us different ways by which we can encrypt images. And it was a very fun project because we were able to discover different tools to use to encrypt images, regardless of the final one we use. So we learned a lot. We learned how to secure images, use C++, which we're not familiar with. We use Python. We use a lot of different programming languages, and it was a very educative project. So, but in conclusion, we were just able to design a very effective encryption and compression system. Uh, below is our references that we were able to get in the completion of our documents. So in the next slide, you would see the references we got. There are six of them, and these are our sources that we used to complete our project. Thank you very much.
Thank you.
Thank you, everyone.